Hey guys, so this is your last set of notes for Unit 3, and it's just all about choosing the best method for solving a system of linear equations. So you're just going to get some extra practice with these two methods that we talked about already and that we learned about already, and that's the substitution method, which is where if you have equations like pictured here below, where one of the variables is by itself, then you're most likely going to use the substitution method because the variable is by itself or very nearly by itself, okay? And then you also have the elimination method, which is we're going to use this method when your variables are lined up and opposites are one another so that you can eliminate one of the variables, or when none of your variables have a coefficient of 1. So usually when none of the variables have a coefficient of 1, then you're going to be able to use the elimination method. So notice in this example of elimination method, you would use it here because the y's would cancel out. And here you would use it because there's big numbers here, and the best way to do this would be the elimination method. Okay, so substitution is when one of the variables is by itself so that you're able to substitute into the other, and elimination is you have to get rid of one of the variables in order to solve. Okay, so let's look at these few examples. This does not have any practices in ALEX, so I'm going to go through a couple of these examples with you to show you how to solve for the best method, and then I'm going to have you try the rest of them on your own. So in number 1, I can tell that both of my equations are set up to be y equals. So right off the back, I know that I'm going to use S, which stands for the substitution method for this one, because one of the variables is by itself. Actually, both are by itself. So what I'm going to do is I'm going to take my second equation, y equals x minus 4, and I'm going to plug it in for my y in my first equation. Okay, and let's see what that looks like. So we have x minus 4 is plugged in for your y is equal to negative x minus 6. And then what I want to do is I want to solve for the x. So I'm going to add x to both sides as my first step. And then I get 2x minus 4 is equal to negative 6. Then I'm going to add my numbers onto the other side, and I get 2x is equal to negative 2. And if I continue over here, I've got 2x equals negative 2. I'm just going to divide by the 2 to solve for x. So my x is negative 1. Now, in order to solve for the y variable, make sure you always go back and you plug your x into one of the equations, doesn't matter which one. I think for time's sake, I'm just going to plug it into the second equation for my x because there's no negative symbol, so I don't have to worry about that. So for my y, I would have y equals negative 1 stands for x minus 4, which is negative 5. So our final answer here would be written as an ordered pair, negative 1, negative 5, as a solution to this system of equations. Okay? So all you're doing is you're looking at the equations, you're seeing which method you can use, and then you're using that method. So if I look at my next equation, I have negative 2x plus 2y is equal to 6, and 4x plus 2y is equal to negative 6. I can tell that I can almost get rid of my y's. In fact, because they both have the same coefficient of 2, but I do need them to be opposites. So noticing that, I know that I'm going to use the elimination method for this one because I know that I can easily get rid of my y's by doing one simple thing, and that's timesing everything by a negative in my second equation. When I do so, I get negative 4x plus 2y is equal to negative 6. And then what I'm just going to do is I'm going to rewrite my second equation underneath this one so that they line up. So I've got negative 2x plus 2y. Whoops, I'm sorry, I didn't distribute the negative in. So if I don't distribute the negative in, it actually ruins my whole problem. I forgot to distribute it to the 2y and to the negative 6. So I'm going to make this a negative 2y when I distributed it in. And then this is actually going to become a positive 6 over here. Okay? So just negative 2y and positive 6. And if I recopy the rest of my problem from the top, I still have the negative 2x plus 2y is equal to positive 6. Now I can line up the two and solve. So I can get rid of the y's. Those are gone. And negative 4 minus 2x is negative 6x. And 6 plus 6 is 12. So if I continue that over here, I've got negative 6x is equal to 12. Divide by both sides by negative 6. And I get x is equal to negative 2. There's my first part of my answer. Don't forget, we always have to find the y, so we're going to take this x equals negative 2, and we're going to plug it into either equation, does not matter which. I'm going to plug it into my top equation for x, and it's going to look something like this. So I'm going to have negative 2 times negative 2 plus 2y is equal to 6. Well, negative 2 times negative 2 is positive 4 plus 2y equal to 6. I'm going to get my numbers onto one side, so I'm going to minus the 4. And I get 2y is equal to 2. And then if I divide the 2 on both sides, I'll get my y is equal to 1. Okay, so my final answer here as a solution to the system of equations, I have the ordered pair negative 2, 1 as my solution. And that one was using the elimination method. If we look at number 3, we have to decide from number 3 which method we would use here. I've got coefficients or numbers out front of the variables that are greater than 1. And I notice that I do have opposites with my x's. So I know that I can use the elimination methods for this one because I can get rid of my x's just by adding the equations as they are. So if I do that, I get 5x minus 5x is gone. 4y minus 2y is 2y. Negative 7 plus 1 is negative 6. Divide both sides by 2 and you have your y is negative 3. Don't forget to plug that back in so you can find your x. So y is negative 3. I'm just going to plug it into my top equation because I think that might be easiest. We'll see. So I have 5x plus 4 times negative 3 is equal to negative 7. 4 times negative 3 is negative 12. So you got 5x minus 12 is equal to negative 7. Then you want to get your numbers onto one side. So I'm going to add 12 onto both sides. And I have 5x is equal to 5. Almost done. Divide both sides by 5. And x is 1. So a final solution to this equation, to this system of equations, is 1 comma negative 3. Okay, there's our two answers. X is 1, y is negative 3. And that's again using the elimination method. You'll notice in your notes that you have a second whole page up to number 8 of solving systems of equations. I'm going to do one more with you, and then I'm going to have you try the last 4 on your own as practice. There is no practice in Alex for this one. It is just on the worksheet or in the packet. Okay? So in number 4, I notice right off the bat that one of my variables is by itself. My y is by itself, and it's equal to negative 2x minus 3. So what I'm going to do is I'm going to plug that negative 2x plus minus 3 in for my y in top, and that is called the substitution method. So I'm going to use the substitution. I'm going to take that y and I'm going to plug it in and we see what we have. So when I do that, I have 2. I'm going to open up parentheses because I'm replacing my y with negative 2x minus 3 equal to 2x plus 12. So first thing I'm going to do is a multi-step equation. I'm going to multiply the 2 into both pieces, distribute it in. So you've got 2 times negative 2 is negative 4x. And then 2 times negative 3 is negative 6 equal to 2x plus 12. Then I'm going to get my variables onto one side and my numbers on the other. So I don't want to deal with negatives, so I'm going to add my 4x onto both sides first. When I do that, I have negative 6 is equal to 6x plus 12. And then I'm going to minus the 12 onto both sides. And I'm going to continue over onto the right here. I have negative 6 minus 12 is negative 18 equal to 6x. Divide both sides by 6. X is equal to negative 3. There's one of my answers. So take that answer for x and plug it back into either equation. In this case, I'm going to plug it back into the second equation for my x because I can be able to find my y pretty easily from there. So you have y equals -2 times -3, because that's my x, minus 3. -2 times -3 is 6, minus 3, which is 3. So our final answer here as a solution to this system of equations would be -3, 3. All right? So again, these are just practice problems to try to help you decide which method to use, either the elimination method or um, the substitution method. Give it a try and let me know if you have any questions. Good luck.